Good morning, everyone. I hope you all had a good break over Christmas and New Year. I certainly did, except I seem to have come out of it with a terrible cold. So I apologise all the way through this video. I'm sort of coughing and sneezing. And also at one point my brain melted down, but that's okay. Welcome to my new series of videos that I'm just going to cover random Linux topics. Anything that I find interesting and fun. And the same for you. So I'd really appreciate any suggestions for topics that I should cover. We're now up to an amazing 200 subscribers. Not quite a million yet, but we're getting there. So I must be doing something right for some people anyway. As you know, my approach is sort of nice and slow and gentle, and let's cover things properly rather than go through at the speed of light. Okay, so that's it really. So we're going to cover Logical Volume Manager, and we're going to explain what it is. It's going to be two parts. The first part will cover the basics of Logical Volume Manager, and the second part is going to go down into the weeds, and we'll enjoy ourselves there. That's where we'll cover RAID and things like that. Okay, so let's get on with it. Before we had Logical Volume Manager, then we had traditional disk management, which was less flexible. I mean, you created partitions on disks, and it was a lot less flexible than Logical Volume Manager, as we will see. And the file system was tied basically to the disk layout. If you wanted to resize a file system, and not many file systems actually allowed that at the time, but then it required downtime and backup. So you actually had to basically back all your data up and recreate the file system on a new, bigger disk. And what space you had was pretty inflexible. So a classic example would be you have a disk of a certain size and you partition it in a way that seems sensible when you install this operating system, and then afterwards you realize you've made one of the partitions far too large, and maybe the other one could have done with being a lot larger. But now, sorry, tough, you need to back up, reinstall, and basically recover your data. So it was painful, really. The downside of all those things is the risk that's involved. If you have to actually back up and then restore later, did your backups work, etc., etc. It's not very flexible. And how the hell do you do, capacity planning when effectively a change in capacity involves almost upgrading your hardware? That's what Logical Volume Manager is going to try and address. All right, so the solution potentially is Logical Volume Manager. And the idea is it's an abstraction between the disks and the file systems. So with Linux Logical Volume Manager, you create virtual partitions, which you can subsequently enlarge in size. Okay, and then most modern file systems allow you to grow the file system, so you can grow them. You create this abstraction using multiple disks. In fact, you can do it with just one disk, but you usually create it with multiple disks, and you subsequently can add disks to this pool or this volume group. So if you needed to increase the size of a particular file system, then all you have to do is throw another disk into the pool, assuming you've already used all the available space at the moment, and you can grow into that disk. So it's incredibly flexible. So it's really good. We're also going to see that we can implement RAID, which we're going to look at in detail in the next part. We can do snapshots, which we already looked at when we looked at Proxmox. We did snapshotting in there. And we can also implement thin provisioning. So those things we'll look at in part 2, or possibly part 2, part 3, if part 2 seems to be going on too long. And it gives us total hardware independence. The file systems do not live on the hardware directly. They live on our logical volumes. So that's really cool. That's excellent. So storage becomes virtual. It's no longer physical. History of LVM, where it's been around a long time. I believe that IBM's AIX Unix operating system had the first implementation of LVM. And by LVM in this context, this is not the same software, but it does the same functionality. So all of these vary in the kind of low-level view that you see. And then there are a number of solutions which you'd probably describe as enterprise solutions, such as Veritas Volume Manager, very powerful piece of software that's often described as solving problems you never knew you had. It's very powerful. Solaris ZFS, which is fantastic, really brilliant piece of software, which is basically a logical volume manager and file system and a load of other stuff built into it, but much more complex than LVM and has much more functionality, in fairness. I've got a terrible cold. Sorry, I keep coughing. And then we have ButterFS, which yeah, has similarities to ZFS, and we also have Stratis. So Linux also supports, or Linux LVM also supports RAID. It actually supports a total of 6 RAID levels, one of which is not recommended to use. I don't really want to talk about these here. The ones that we'd want are supported, like RAID 0, RAID 1, RAID 10, or RAID 1 plus 0. RAID 5 and RAID 6 are all supported, and that's great, okay? And we're going to look at those in part 2, but let's walk before we can run. Always a good idea, or you fall flat on your face. So what have I got? I've got a JBOD attached to a server called Tempest, which we're going to use. And in that JBOD, there are actually 5 disks. Okay, so for this initial demonstration, we're going to use 4 of them. And they're actually on that server, they're coming out as dev SDB, SDC, SDD, and SDE, because SDA is the actual boot disk. So these are 4 3 terabyte drives, if I remember rightly. And then I've got a 5th disk, because it's a 5 disk JBOD, and the 5th disk is 8 terabytes. And we'll probably use that more in the next part. But this is what we're going to play with today, these 4 disks. Okay, so we got 4 physical volumes. That's how they are referred to in Logical Volume Manager. And the first thing we need to do is, I'm careful how I use this term, but format them for LVM. So what that actually does is this. It basically takes these 4 physical volumes and it creates what are known as extents. And extents are chunks, 4 megabyte by default, so 4 megabyte, and it splits these 4 disks into little 4 megabyte or megabyte, being technical, chunks, which we will use to build things with. So that's where we start. And how do we create these extents? We use a command called pvcreate, and I've given you an example there, and we're going to go and do it right now. Okay, so here we are on Tempest, which is the machine we're going to use, and this is the machine that has the JBOD attached. JBOD, just a box of disks, as opposed to a RAID device. So this device does not support hardware RAID, whereas some do, and they would typically be referred to as an array. So first of all, let's start off by familiarizing ourselves with the hardware on this machine. So we do an LSBLK is probably the simplest way of doing this. And this will actually show us that we have various disks attached. One of them is SDA, which is in use by Ubuntu as its boot disk. And we also have SDB through SDBF. And we can see that SDB, C, D, and E are all 3 terabyte or 2.7 tibibyte disks. And SDF is actually an 8 terabyte or 7.3 tibibyte disk. So first of all, let's actually see what aspects of Logical Volume Manager are already configured. Now, Logical Volume Manager is installed on this machine because I chose to install Ubuntu using Logical Volume Manager. Some distributions you may need to install it separately, which is simply an apt install LVM or a DNF install or yum install LVM. So it's very simple to do. So you need it installed, obviously, to be able to do the following things that we're about to do. To start with, let's look at how many of the, which of these disks have actually been put under Logical Volume Manager control. The easiest way of doing that is with the command pvs, which stands for Physical Volume Status or Physical Volume Show, whatever. And of course, we should see that in fact only one of the disks, in fact it's a partition in this case, SDA3, is under Logical Volume Manager control, and that is our boot disk. So we can also use a PV display command, and it will give us a lot more information so we can see that we have 4 MB extents. We can actually see the unique ID of the disk itself. We can see things like how big is the disk, etc., etc. Um, so PV display is great if you really need to look at detail, but PVS, as you can see, it tells us what we need to know. So the next thing we need to do, as on the slide we've just looked at, is use a PV create command. Now, normally we just take the defaults, so things like extent size of 4 megabytes, etc., etc. We can actually use options to actually choose different extent sizes and things like that, which is quite unusual to do. So we're not going to go there today. All right. So now I need to actually list the disks. So I would need to go /dev/sdb and then /dev/sdc, etc., etc. But we can use a Linux, or specifically a bash shortcut, and we can say open square brackets b hyphen, we want to go to e, close square brackets, and that will actually expand to as if I typed in /dev/sdbd /dev/sdbc, etc., etc. So it just saves typing. So we hit enter on that, and it tells us that it's actually created these physical volumes. Follow that up with a PVS, and we can now see that we actually have the additional 4 disks in there. So having done that, let's now move on to the next step in this. So now we need to create a volume group because our physical volume extents need to be put into a volume group. So I'm going to say that we're going to create a volume group called DataVG. So that's our next step. So let's do that now. Let me clear the screen so it's a bit easier to see what's going on. Remember, PVS shows us that we have our 4 physical disks. So now we want to do a VG create, okay, and we want to give a name of a volume group, and we called it data VG. And then we have to specify the disks we want to put in there. And we can say dev sdb hyphen e. I seem to have got 2 square brackets, and hit enter. Okay, now we can do a VGS, and that actually shows us that we've got the Ubuntu VG group that we created when we installed Ubuntu, but we have this additional data VG. And similarly to PVS and PV display, we can say VG display, and that will give us far more information. So if we need, for whatever reason, to drill down into the actual detail of that, we can do using VG display. But let me just clear the screen again. Most of the time, PVS and VGS are going to give us a much clearer output that we can consume quickly and actually understand what on earth's going on there. Now we need to think about actually creating logical volumes. So we're progressing nicely here. So we can use the LV create command. So notice this lovely symmetry of the commands. So we had PV create, VG create, LV create, and we had LVS, VGS, and guess what? We're going to have LVS and LV display. So it's really nice in that sense. It's nice and consistent. So what I've said here is let's create a volume of 1 terabyte. All right, and that's so we can go and create that volume, and it will use space in the data VG. What space will it use? We don't care. We just say, right, here's a bunch of disks. Create me a 1 terabyte volume. Now, if we cared for some reason, it is possible to go and drill down and actually find out which disks, the extents that we used to create our new volume came from. We could ask that question, but most of the time we don't really care, to be honest. Perhaps we should. So that's the next step. So use an LV create command to actually create ourselves a volume. We do an LV create, and we can use long syntax options like hyphen hyphen name. Okay, or we can just use -n as it happens. So what are we going to call it? I've forgotten what it was. Data VG, no, data vol -01, I think. So I think that's what I said on the slide. And then we can use minus size, and I said 1 terabyte, 1T. Minus size, you would think, it'll be -s, but no, it's not. It's minus capital L for length. But anyway, so it's not 100% consistent. So we're saying we want to create a 1 terabyte volume and we want to call it datavol-01, and we have to end the command with, well, where exactly do you want to create this? Because we might have multiple volume groups. In fact, we've got two, but we want to put this in our data VG. Hit enter, and it says it's created it. So we know the plan now, LVS, logical volume status. And lo and behold, we can now see our datavol-01 that's in data VG, has various attributes which we will talk about in part two. Actually, I want to keep this particular uh, part short. And how big is it? So it's a 1 terabyte in size. And of course, we can do an LV display, and we can specify what we want to actually display, by the way, because if I just do LV display, it's going to show me all logical volumes. If I want to see a particular one, I can say data VG slash, and then the name of the actual volume. So it's data vol-01. So I'm saying I want you to display information about data vol-01, which is in the volume group data VG. Hit enter, and it comes back and tells me all about it, all right, in detail. But the LVS told me enough. So I like the PVS, the VGS, the LVS. They're nice commands because they tell you probably what you want to know without bombarding you with information that you probably already knew, if you know what I mean by that. Okay. So we now have a volume that's 1 terabyte. If we do an LSBLK now, it will actually show that we've got, and it tells us that the data vol that we created is actually on /dev/sdb, which is hardly surprising. That's the first disk in the 4 disks that happen to be in data VG. So it would be slightly strange if it had put it somewhere else. But there you go. Now, if we'd have asked for a 5 terabyte volume, then it probably would have spread across into SDC. So that's pretty cool. So let's now go back to our slides. We've created this volume. So what's the next thing we want to do? Well, we actually want to use the damn thing. We want to do something with it. So the first thing we do is a mcfs. We then make a directory, and then we mount that device onto that directory, and actually not mentioned there, but then we would go on and probably put an entry into etc. fs tab. And by the way, let's just have a look at ls of /dev/data vg, and in there we can see our volume. Okay, so first thing we're going to do is actually make a file system. What type you want to make? Well, it could be .xfs, .ext4, whatever file system you want. So make a file system on /dev/data/datavol01. So that took a few seconds. This JBOD, by the way, is a USB JBOD, so it's not the fastest disk of bunch of disks. So now we have a file system on data VG datavol01. We now need to mount it somewhere. So let's make a directory. So make a directory called /datavol-01. Mount the device /dev/datavol-01 onto /datavol01. Okay, and now if we do a df-h, we can see at the bottom here, we can see the device has mounted. So it turns out that the dev data VG datavol01 makes life easy because it actually shows us the volume group, etc., etc. But at a lower level, we're actually using part of the kernel, which is known as the mapper, device mapper. And so it's actually pointing us to /dev/mapper/data-data VG-datavol01. So now we should follow that up by actually editing, assuming we want to do this, of course, editing fs tab. And we should add in there an entry for that disk. So /dev/data VG/datavol-01. Have I got it right? Where do we want to mount it? Onto /datavol-01. We need to specify what type of file system it is, ext4. What options would we like? So we just go with defaults, and then we want to say how often do we want to dump this file system? 0 means I never want to back up this partition or this device. And the next thing is, how often, in what order do you want to run FSCK? And we're going to put 0 because we don't want it to run FSCK on it boot time. By default, we want it just to, we can do that manually. It will flag us if there are any errors. So we then hit escape, we save that, and then a good thing to do, if you've updated it, etc. FS tab, to check that your syntax is correct, is first of all to unmount the device. So we'll unmount /datavol01 and then remount it. Okay, and if we've got our syntax correct, we should be able to mount it simply by specifying the name of the directory. If I've made a mistake in there, at this point, it will explode. Oh, by the way, because we've modified /etc/fs tab, then we do have to inform systemctl because it basically has cached the old version. So we can use systemctl and do a daemon-reload. That will get it to refresh its cache, and it will pick up the fact that etc/fs tab has changed. All right, so if we, let's clear the screen. If we do an LVS, just to remember, we've created a data vol of 1 terabyte, and we've now basically started to use Logical Volume Manager in its simplest form. This is not covered RAID, as you well know. Okay, so what I want to look at now is the idea of actually creating some more volumes. Okay, so if we say search for create, LV create minus name datavol01, let's change that to datavol02. Size, well, we've got a total of 2.7 times 4 terabytes. Now this is going to take time, so I will definitely edit this, but let's make a 6 terabyte, not 61 terabyte, we might struggle with that. 6 terabyte volume in data VG. This will take longer than the last one. Actually, the creation of the volume doesn't take much time because all you're doing is creating metadata that says there is a volume of this type. Control R, MKFS. What will take, and let's actually change this slightly for whatever reason, just because you can. Let's make this XFS, and let's make this datavol02. Okay, it's completed. That did take significantly longer than the last one, but that's okay. But we now should have a 6 TB file system on our 6 TB volume. So next thing we need to do is create a directory. I'm going to cheat here and just recall the previous one. Okay, so mkdir /datavol02, not very imaginative, am I? Then we're going to want to mount it. So let's run the mount command. Okay, so okay, and now let's do a df -h of /datavol02, and we can see that we've got a 5.9 TB file system mounted on /datavol02. Yeah, that's correct. It's all right. And now we need to vi fs tab again, copy and paste the line before, replacing 1 for 2. And of course, I've got to change the type because it's not ext4. This one was XFS. We've saved that. Now we need to do our reload to tell systemctl that we've actually made a change that it needs to notice. Now we can do our umount of /datavol02, and now we can do our mount again of /data, proving that our entry in fs tab was okay. Now if we do it df -h, we can see at the bottom we've got a 1 terabyte volume called datavol01 and a 5 terabyte volume called datavol02. Okay, and finally, to complete the picture, let's actually do an lsblk and see what it is that we've just created, this 6 terabyte device. And what we're expecting to see is that it actually spans more than one physical disk. So if we come over and have a look at this, let me clear the screen for clarity. So if I do an lsblk, sure enough, if we look down here, we can see datavol-01 is on SDB, and datavol-02 is actually on SDB, SDC, and SDD. It's actually spread across to 3 disks. And that's all been done by magic, the magic of Logical Volume Manager. To wind up this section, what I would like to do is 2 things. One of them is I want to actually show you how you can destroy all that, okay? And the easiest way is to actually do a VG remove, all right? So all these commands I think are really intuitive. Yes, we've got PV remove and we've got LV remove. So once you get to know the general syntax, it's very, very easy to remember the commands. We want to do a VG remove of data VG. Now, you might say, well, shouldn't we have removed the logical volumes first? We've got 2 logical volumes in that data group, in that volume group. And the answer is you don't have to actually, because what will happen is it will say, are you sure you want to remove VG, data VG? And I'll say yes. And then it basically, oh, they're all mounted. Oh, of course. This is good actually, because it's showing that it's going to protect us from really screwing up. You really need to mean it when you say you want to remove these things. We need to unmount slash data vol 01 and slash data vol 02. So if we now do a df minus h, we can see those 2 volumes are unmounted. And what we're going to use, as we said earlier on, is a VG remove command. So we're going to do a VG remove data VG, and it will actually come back and say, are you sure you want to remove it? And we'll say yes. Do you want to remove that? We say yes. And it says, okay, I've removed that. Oh, there's another one. Yes, remove that one as well. Okay, that's fine. So if we do a VG, a VGS, keep it simple, we see there is only 1 volume group. But if we do a PVS, we can see that our 4 disks are still known about. So that's going to potentially create problems in the future. So to take this story all the way, actually, with what we're doing, really, we could just leave those in there because we're still going to use them for Logical Volume Manager. But to take the story the full way, we would do a wipe fs minus a for wipe all metadata from /dev/sd b through e. And we can see here that it's now actually removed the metadata. So if we now do that PVS again, it only shows the Ubuntu device SDA3. Okay, so now I want to take this one step further. Remember, we've got an 8 TB disk. Okay, so we've got an 8 TB disk available to us, but we don't have anything else. So how can we play with Logical Volume Manager with a single disk like that? And the answer is there's a trick you can use. It doesn't make sense most of the time, but for the purposes of learning, it could be very useful. And basically, what we're going to do is partition that 8 TB disk into 4 roughly equally sized partitions, and then we can pretend each of those is a disk. So if you don't have a handful of disks to play with, but would still like to play with some of the RAID and things like that we're going to look at later on, then this is one way of doing it. So how would you do it? We do a gdisk. We can see that this disk is currently unused. It's got no partitions on it. So we're going to create some partitions. And the syntax I always find a teeny bit painful, but we say n for new, partition number 1 by default, the first one, that'll do. Says, where do you want to start? Well, I'd like to start at the beginning of the disk. Hit enter, and it says, what's the last sector? So you can actually specify a sector and things like that. But, and by default, it'll take the entire disk. Well, we don't want to do that. We want to specify a size. So we want to say, let's say 2.4 TB. But you can't do that. You can't, you have to have an integer there. So we'd say 2400 gigabytes, which is roughly 2.4 TB. Hit enter, default on everything else, do a P for list of partition table. We can say we've got a 2.3 TB partition. So let's create another one, new. Default for the number will be the next available number, 2. That's pretty good. Says, what's the first sector? Well, it'll give us the first available sector after the previous partition. So again, hit enter. And here you have to actually put plus. And what did we use? 2400. So we'll just repeat that. 2400 gigabytes. And again, hit return, do a P. We've now got two partitions of roughly the same size. So we can now create another partition, N for new. N for new, default partition number 3. What's the first sector? Well, the first available sector on the disk. How big? 2400 gigabytes. And then just default on the other, and then do P again. And it's so far looking pretty good. So we just want the last one, because we want to create 4 in my example anyway. So the last one, default value is 4 for the partition number. The starting sector is the first available. The last sector, we're going to put a size plus 2400, not gigabytes. We'd have a job getting that. And then, no, it's not happy with that. Plus, what on earth have I put there? No, that's correct. 24, maybe, actually, let's just hit enter, because perhaps there isn't 2400 gigabytes left. I knew there was a risk this would all go horribly wrong. So we'll just hit enter and it'll use the remainder of the disk. Do a P, and in fact, 252. 3 2s are 6, 7. Yeah, I'm completely cocked up on this. But you see the sort of basic idea of what I was trying to do. I've cocked up, but never mind. I can't divide 7.3 by 4, obviously. Where on earth I got 2.4 gigabytes from, God alone knows. Anyway, we'll write that, whatever, let's carry on, you know. So W for write. Yes, I do want to proceed. It's written the partition table. So now if we do an ls/dev/sdf, wasn't it? We now see we've actually got 1, 2, 3, 4 partitions /dev/sdf 1, 2, 3, and 4. So I can now do a pv create. Obviously I've cocked up. These should be roughly the same size for it to be meaningful if we're going to try and use this for RAID. But anyway, let's carry on. Carry on regardless, and then when we come to do RAID, and I'll repeat this little process, I'll do it properly next time. I'll actually work out how big they should have been. So we can say pv create /dev, and if we now do a pvs, we can see that we've actually got our 4 virtual disks, and we could create a logical volume manager, right? So logical volume within there. So the first thing we need to do is create the volume group. So let me find the command vg create data vg, but this time, instead of saying create it with SDB through SDE, we can say create it with SDF star. And so we can see, having created those, I cocked up again, by the way, but I'm going to edit that out because I'm an idiot. We could actually see that by doing where is it here, VG create here, data VG/dev/SDF star, okay, it actually came back and complained, and I thought, oh, that failed, and I was thinking, why has that failed? And of course, it's because an asterisk means match anything, including nothing. So it tried to use /dev/SDF, and it was basically saying, no, you can't use that because dev SDF has been partitioned. So it says can't use dev SDF devices partitioned. Okay, so it couldn't use it, but it did actually succeed in actually doing a PV create on the other partitions. So we do have SDF1, SDF2, SDF3. You can't get the stuff, can you? Honestly, I've only been playing with Unix and Linux for the last many years, and I still make mistakes left, right, and centre. But there you go, whatever. So we've now got 4 volumes. Sorry, 4 devices in our volume group. So we can now create our volume group. So we have done already. I'm losing the plot here. VGS. We've got no, we haven't. VG create data VG. Ah, right. So if we do the VG create again, sorry guys, VG create 1-4 instead of SDF star. All right, now we can do the VGS. And we can see that we have actually got a volume group called data VG, which is 7.2 terabytes. We can now do things, create a volume. So let's do an LV create. Yeah, let's create a 6 terabyte volume in data VG. Okay, now that volume is definitely bigger than the individual partitions that we created. So let's do an LVS. We can see the volume exists. It's 6 terabytes. Let's now do a MKFS. So let's do a MKFS of dev data VG data vol02. That'll take a few seconds. So I will actually edit this slightly so you don't have to sit there waiting for it. Okay, that did take a few seconds, but it worked, so that's all right. So we've now created a file system. So we can now do a mount. We can mount it onto data vol02, which I didn't actually remove that directory before. So that's worked fine. If we do a df-h, we can see that we've got a 6 terabyte disk mounted. Well, 5.9 terabytes available, but it's mounted under /data vol02, so that's good. And apparently that's made from 4 separate physical disks in the data VG group. Now we know it's actually the same disk, but I'm remind you that you're probably totally confused now, but I'm reminding you that I'm just showing you what you could do if you've only got one disk. That doesn't matter. You can still simulate having many disks. And if we just clear the screen, and if we do a VG display of data VG slash data vol-02, invalid to go. What did I go? It's getting worse, guys. Data VG, data vol-02, VG display. How about we do an LV display? It's getting worse. Okay, so we can actually emphasize the fact that this is only one disk by doing ls BLK. I tell you what, let me select the screen, that might help. If we do an ls BLK, then we can actually see down here SDF is 4 partitions, and each of those partitions has part of data vol-02 /data vol-02. So I think that kind of shows it nicely. Okay, so that is part 1 of Logical Volume Manager, complete with all cock-ups, of which I made many in the last few minutes, for which I apologize. And watch this space for part 2. And if you haven't already subscribed, please do. Okay, you don't want to risk it. Whoops, where is he? He's up there. You don't want to risk it. You know what Big Dave told you in the last session? Subscribe or else. Okay? Do you like my little mate? After the last, if you've not watched my Proxmox videos, you won't know what the hell I'm talking about. But after my last video, which I think I had a bout of insanity, and my brother Big Dave came in and threatened to turn you all into wombles if you didn't subscribe, I actually went onto eBay and managed to get myself a womble, because I've never owned a womble before. So say hello to little Eddie, okay? Oh God, I think I need help. Bye, see you in part 2, which hopefully won't be too long.